So, number one, we have f of x, f function equals log base 1/5 of x, g of x equals 7 to the x. Okay, so 1a. 1a is worth 2 points for those of you who took the test. Find f of 25. So we're going to go to the f function, and wherever we see x, we're going to replace it with 25 in the f function. So f of 25 is the log base 1/5 of 25. So our brains don't think so well in logarithms. So what we want to do is change this from a logarithmic equation to an exponential equation. And f of 25, that's really y, log base 1/5 of 25. And so we're going to change this into an exponential equation. So we have 1/5 to the power y equals our quantity 25. So once we have that, we want to use the one-to-one property for logarithms, and we want to get the same base on each side. And so we want to use the base of 1/5 so that they match up. So we have 1/5 to the y equals, to get 25 out of 1/5, we're going to have to square it and invert it. So power -2. And so now we know that y equals -2. Or another way to say that, f of 25, because that's y, equals -2. So that's our first question. That was worth 2 points. 1b has find g of 1. So we're going to go to the g function, and wherever we see x, we're going to replace it with 1 in the g function. So we're going to have 7 to the first power. This one's very easy. So g of 1 is 7. That's it. There's our answer for 1b. And that was also, by the way, for those of you who took the test, worth 2 points. Number 2, worth 4 points. Rewrite the expression as a single logarithm. So we have 2 times the log of x plus the log of y minus the log of z. That's a z with a line through there. So what we want to do is we want to think about order of operations here. They all have the same base of 10, so we can combine them as a single logarithm. So with the order of operations here, what we want to do is we always do multiplication before we do addition and subtraction. So this 2 times log of x, that's really the power rule. So we're going to rewrite this as the log of x squared. And we'll take one step at a time, plus the log of y minus the log of z. Then going left to right with addition and subtraction, 2 separate logarithms, same base with addition, become a single logarithm with multiplication. So this is the log of x squared times y minus the log of z. And now 2 separate logarithms, same base of 10 here, with subtraction become a single logarithm with division. So our final answer here is going to be the log of x squared y over z. For those of you who took the test, that's worth 4 points. And if you have questions about grading, you can see me after, okay, on grading. Okay, question number 3. Also worth 4 points. Rewrite the expression using sums and or differences of multiples of logarithms. So ln of 3x over y squared. So this is kind of the reverse question from question 2. So first thing we want to do using order of operations is the fraction bar is a grouping symbol, so we want to work with groups. So to separate a single logarithm with division, we're going to make that 2 logarithms with subtraction. This is going to be ln 3x minus ln y squared. So technically, next we would want to work with powers before subtraction or multiplication. So I'm going to take that y squared, and that's the power rule. So we have ln 3x minus 2 times ln y. And then finally the ln 3x a single logarithm with multiplication, we separate as addition. So this is going to be ln3 plus lnx minus 2 times lny. And so we are done. And of course, you all might have fewer steps than me, but that's in the end, that's our answer. So, on to number 4. Number 4 says, graph this function, f of x equals 1/2 to the x. We want to graph this on graph paper. So, another way to think of this is y equals 1/2 to the x. So based on the way this was written, I'm going to use colors here. Based on the way this is written, we want to choose for x in order to get y. That's the easiest way to do that. So I'll do this in blue. And the power x in an exponential function, the domain x is all real numbers, so we should definitely choose negatives and positives and 0 for x. So I'm going to pick -2, -1, 0, 1, 2, kind of our usual basic numbers we pick to get the full picture here. So first of all, 1/2 to the -2. We square it and invert it, right? And so that's going to give you 4. 1/2 to the -1, we invert it. That's going to be 2. 1/2 to the 0, anything to the 0 power is 1, except 0 to the 0 power. 1/2 to the first, 1/2. And 1/2 squared, 1/2 times 1/2 is 1/4. So, going to the graph on that one. Making our graph. And of course, everything's more accurate with graph paper, obviously. Should try to be more accurate since I'm on video here. Try to make that better. Okay, so in blue, I'm going to graph these points. So I'm going to go left 2, up 4. And then left 1, up 2. And 0 left or right, up 1. Right 1, up 1/2. Right 2, up 1/4. So here's my basic function f of x, which is with an exponential function. It's a one-to-one function. The domain is all real numbers. The range is 0 to infinity, so it meets all those criteria. It has a y-intercept at 0, 1. So we're going to take that question, number 4, by the way, which was worth 3 points. Number 4. And we're going to go to number 5a. And 5a says, using that basic function, graph g of x equals 1/2 to the x plus 1, minus 3. So everything's on the board. Maybe you take a picture of this later. By the way, if you all are thinking about retakes, the retake information, I don't know if you need it, but it's here. Purnima and Don Larry, if you're thinking about retakes, the information's here. Okay. I don't know if you are, but anyway, that's there. Pick it up on your way out. All right, so on to number 5. We're doing 1/2, g of x equals 1/2 to the x plus 1 minus 3. So the way we do it is that we take our original points and we just take our original values and we do the shift, the translations from our original point. So I'm just going to go to this table here. You can certainly pick all new points if you want, but I'm going to go to this table here. It's a little bit easier. So we have, because we're adding 1 to x, we do have a horizontal shift, but with horizontal shifts, it's always supposed to follow a minus. So are we shifting 1 unit right or 1 unit left? 1 unit to the left, because this is x minus -1. So what we do is we're gonna take our original x's and we're actually going to subtract 1 because this x plus 1 tells us it's a shift 1 unit left. So original x is minus 1. So that's gonna give me -3, -2, -1, 0, and 1. For y, this is a vertical shift. It's going to be up 3 or down 3 if we're subtracting 3. Up 3 or down 3? Down 3. So we're gonna take our original y's and subtract 3. I'll do that in green to get a different color. So 4 minus 3, 1, 2 minus 3, -1, 1 minus 3, -2. 1/2 minus 3 is -2.5, -2.5. 1/4 minus 3, -2 and 3/4, -2.75. That's it. Again, you can pick all new points if you want. If there had been a number that you're multiplying out front here, that would be a stretch or a shrink. If there'd been a negative, it would have been a reflection. So I'm gonna just now graph the green points on the same axis, and we'll have our shift left 1 unit and down 3 units. So -3, 1, left 3, down 1. Whoops, here. -2, -1, left 2, oh, sorry, let me try that again. -3, 1, left 3, up 1. -2, -1, left 2, down 1. There we go. -1, -2, so left 1, down 2. 0, -2.5, so 0 left or right, down 2.5. And 1, -2 3/4, right 1, down 2 3/4. So here's my g of x function. So there's my new function, and in 5a, that one was worth 3 points, that graph. For 5b, identify any asymptotes. So normally on an exponential function, you have a horizontal asymptote of y equals 0, as we saw here, the x-axis. But because on this one we shifted down 3 units, now we're gonna have a new horizontal asymptote at y equals -3. Normally it's y equals 0, but again, we shifted down 3 units, so now it's y equals -3 for our horizontal asymptote. Next question on question C, whether the function is increasing